Okay, no problem. Okay, let's look at what we want to know about. Boleh mula? Apa benda yang nak tahu tu? Okay. Sekejap ni. If you just go to the lab protocol tu, dalam lab protocol ada tak muka surat, I think page berapa ni? 14 kot. Ya. You follow strictly as what guided by the table kan? Okay. If you look at S0, that's supposed to be the initial concentration of your starch. Betul tak? S0 tu lah. Your concentration, the initial concentration, betul kan? And then the SF tu, once you put your carbohydrate, your starch tu into the processes where you're going to do you add with enzyme, lepas kita incubate, remember? Okay, once you've got that result, so that is where we're going to measure the leftover of starch. Betul? And then how you get the SF? How you get the SF is by S0 minus SF. So you tahulah the difference of berapa starch yang telah digested. What is the amount of starch that has been digested? Yang tu clear tak? You have to make that things clear dulu. Okay. Substitute. Okay, okay. Okay. Betul. The one that you got from your desmos, that is the remaining of starch. Meaning that you have, in order to identify how much starch has been digested, kan, kita kena tolak lah. Maksudnya starch asal, tolak dengan leftover, so that delta S, that the one in column, the third column tu, delta S ialah yang telah digested. Berarti you know that these are all the starch that have been converted into maltose. Jelas tak tu? So you have to understand what does it mean by delta S tu sendiri. So when we put S0 minus SF, meaning that the initial starch concentration ialah S0. SF ialah the remaining of starch. The remaining. Maksudnya kalau misalnya kata let's say SF F tu ada 10 glucose. Just assume lah ada 10 glucose. Once you treat that 10 that polysaccharide that contains 10 unit of glucose, when you put in the enzyme, it will digest at certain rate. Kan dia akan digested. Once you dah digested, because you set the time for 10 minutes, within 10 minutes, it will break the bond, the glycosidic bond, and form it into maltose. Maksudnya 2 glucose, 1 maltose kan? So let's say after 10 minutes, if you stop the reaction, we still have starch yang which is not yet digested. We still have that leftover of starch yang boleh digested by the enzyme. So that remaining ataupun the leftover tu lah SF. Yang tu kena clear dulu. Dapat tak? Okay. Sekarang berarti once you dapat S0 and F, what is the product? Product dia apa? Because the product should be maltose. So we are not measuring the leftover to product dia ialah delta S. So all this delta S ialah yang telah terhasil due to that the digestion. Delta S tu. That is the product. Itu molekul product. Then what? Because if you want to measure Lineweaver-Burk plot, berapa amount, cuma tahu berapa amount of starch that been converted to maltose. We don't know the exact amount of maltose kan, because we don't measure the maltose. But we know berapa starch yang telah ditukar menjadi maltose. Berapa banyak starch yang telah ditukarkan menjadi maltose. So that is the delta S. If you start off with S0 is milligram per mil kan. Let's look at 1 milligram per mil. After that 10 minutes of digestion, and then it seems that we still have 1.22 of starch concentration. Kita masih ada lagi that amount of starch 1.220 tu kan. But berapa banyak starch yang dah telah ditukar kepada maltose? It is 0.220 tu. So 0.220 is actually the amount of starch that has been converted to maltose. Jelas tak yang tu? Yang tu kena jelas. Okay. Sekarang ni, when we use the Lineweaver-Burk plot, kalau kita tengok Lineweaver-Burk plot kan dia macam lain sikit kan, dia punya plot kan. The plotting where if you look at the notes in Michaelis-Menten, ada nota tak with you? Do you have your notes with you? Cuba tengok kejap enzyme punya notes. Tak, nota. Di sini the resource dalam dia punya, dalam resource pun ada kan on enzyme tu. You can use either one lah. Nak guna ebook pun boleh, nak guna NF pun boleh. Okay, apa yang dapat tu tengok. Itu kat mana you tengok tu? Nota eh? Okay. 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 Would you please share that notes? You tengok Michaelis-Menten kan? Sebenarnya dalam
Doktor nak
video ni
tanya,
pun
kalau nilai delta S tu saya dapat negatif, macam mana doktor?
negatif. Kejap. Kita satu-satu dulu. Kita buat
Satu-satu.
mastery learning dulu satu-satu.
Okey, baik doktor.
Actually, Darshini, if you go to that Google Sheet kan you dapat, when you flip daripada mana? Daripada Google Sheet punya resources tu kan. There's an explanation video enzyme kinetic kat bawah tu. I think if you go to that, you will understand better lah. You will understand. Di situ saya terangkan macam mana dapat. But anyway, tak apa je. So if you want to share with me that slides, that slide pula, notes tadi tu, Michaelis mental model tu. Tak boleh buka? Boleh. Okay, if you scroll bawah ke situ kan. Okay, lagi. Look at the graph dulu. Ni. Ini Michaelis Menten punya graph. If you look at paksi Y kan. Axis ialah velocity. Betul. Y axis T. X axis is concentration. Betul tak? Ini kena faham ini dulu. Betul-betul. Okay. If you look at the data that you have with you right now, if you plot velocity against substrate concentration, mana yang tadi tu? Ni. Kalau if you plot that velocity tu, V tu kan, velocity tu tadi siapa? Fiza, you cannot get negative for velocity. Macam mana boleh laju negatif kan? Something wrong with your delta S tu. Usually kat situ lah delta S dia akan berlaku sedikit when you have that SF and then you tolak, you just get dia punya berapa banyak starch yang telah digunakan untuk menghasilkan maltose tu, you're gonna have that delta S. Nilai delta S. Kalau you tengok, if you want to plot Michaelis Menten, you gonna require nilai V. V tu ialah velocity kan. How V ialah delta S over T. Betul tak? Delta S that you are measure how much product is being produced over time. Tadi sebab tu saya insist you to understand juga what is delta S. Delta S tu ialah berapa banyak starch yang telah digunakan untuk menghasilkan maltose, hasilkan produk. But we don't measure the maltose, we measure berapa banyak telah digunakan. Berarti kita tahu itu produk sebab dia akan hasilkan maltose. So velocity ialah, velocity is in a system when we have our substrate and then put in enzyme and then we measure how fast that system, that environment within a certain time. Waktu ni you buat incubate berapa? 10 minit T600 10 minit. Dalam masa 10 minit berapa banyak produk itu akan terhasil. Berarti in this case we are actually measuring how much amount of maltose, but we are not using maltose. Kita tak guna indicator for maltose, kita terus guna starch kan. Kita buat terbalik tau. Kita buat terus, kita measure berapa banyak starch digunakan. So that delta S is actually how much starch is being used. And then we know that if starch is being digested, it will produce maltose. So dia macam equivalent lah speed itu. The speed will be velocity. We can use delta S ialah yang tadi tu over time. Time dah 10 minit and then you use apa saat ni pun tak apa, boleh je saat ke minit is Boleh as long as keep it constant tak apa. So if you use saat and then it's okay, you use second. So that is the velocity of if you use 0.01 substrate, apa laju dia. If you use 0.5 of substrate, initial substrate tu kan, berapa speed dia. If you use 0.1, berapa speed dia. If you use 1.0, berapa speed dia. Speed apa ni? Speed menghasilkan produk. Kalau dapat negatif, Suzah dapat negatif kat mana?
Dekat data S tu.
Delta S tu. Delta S tak boleh negatif lah. Sebab kita guna starch. It's not supposed to be negative lah tu.
So nak kena ubah data ke macam mana doktor?
Data tu tak pakai. Outlier lah. If you look at this data pun, you nampak tak weight dekat 1.0 tu?
Apa doktor? Tak jelas.
You tengok kat data satu tu. Kolom pertama, snot tu, kan 1.00. Yang bawah tu. The final row tu. Initial, it should not be the SF 1.2. Mana boleh starch ditambah? Ini sudah magic namanya. Sama juga macam yang kat atas tu kan. Supposedly the final should be lesser than S0. It should be smaller than S0 lah. If you look at all of the data pun sama juga tak? Kat mana je yang betul? The first two, the second one kosong tu memanglah kosong. The first test tube you tu, macam ni dia banyak SF lah. So, kalau logically tu it cannot be tinggi. Sebab mesti, because when you have, let's say you have long chocolate bar, bila tiap kali ada digestion, mestilah chocolate bar semakin pendek, betul tak? Tak apa, no worries. You can get this data from others, tengok orang lain punya macam mana. But the concept here is macam tu. SF mesti lower than S0. That is logically memang kena lower lah. Tidak macam ni, data S cannot be negative. Tak apa, let's assume that benda ni betul. The data S tu data betul. SFU tu nombor lain lah, katakan nombor lain lah. Ataupun you punya S nombor lain. Let's assume that how you going to do with what you going to do with the data. If you want to plot that Michaelis-Menten tu, you have to have V over S. V tu velocity lah. V over S0 tu. Supposedly macam tu, yang the y-axis supposed to be your data V max tadi tu kan. V max pula. V tadi tu, V yang data S over. Itu data dia. V tu, mesti over dengan S0 tu. Hilang pula. Tu, subset concentration tu. Yes. So that, yes, exactly. If you plot it, it should look like this. But the issue here is that if we use Michaelis-Menten ni, kita tak boleh nak identify the Vmax. Susah nak identify Vmax because of that line tu, line yang the one that curving upwards tu. At one point dia akan tak jumpa dengan Vmax, the actual Vmax, because of the line we call it asymptotic line. If you remember your math, asymptotic tu kan line dalam math kan, so it will not meet that Vmax, dia akan jumpa because when it move further as some substrate concentration grow, as the number increase, the Vmax line tu, Vmax pula, line V tu, yang the one that black line tu kan, dia akan naik, at one point dia akan stay constant. Dia terus constant saja. Dia tak jumpa dengan line tu, dipanggil asymptotic line. So, there's a way in mathematics how you're going to solve this. Macam mana kita nak solve benda ni ialah simple. Kita buat inverse. Cuba tengok graf you tadi. Nota pula. Data. Ni data ni. If you, what I mean by inverse, tadi kalau if you want to plot Michaelis-Menten, you're gonna plot Y adalah V dan X adalah S0. Betul kan? Faham tak tu? Okay. You're gonna get that line lah. Tapi because of we want to determine the Vmax, so what we do, kita inverse dua-dua data tu. If you look at S0, you already inverted it to 1 over S0. Kolom sebelah dia tu. Kan? That one. And then your V tadi tu pun kita invert juga. So you got 1 over V. Okay, these two data, the last, the right hand side punya two columns tu, we're gonna plot it. Bila you plot, dia akan jadi bentuk lain. Nama dia ialah double reciprocal. Dia akan jadi macam ni. If you look at part CY, Y-axis ialah 1 over V kan? Part CX ialah 1 over S. Yang tadi itulah, yang the one that you inverted tu. Once you invert it, you're gonna draw a line. It will show you something like this. Dia akan intercept at 2 points. Kalau tengok, ada 2 point. Cuba tengok, intercept yang if that line intercept at Y-axis, that means that value tu ialah 1 over X. Katakan, if let's say that value is, let's say 2. Katakan line tu ialah 2. The one that intercepted tu, pada titik tu kan. Could you please just show tu? Katakan 2, so what is Vmax? What over 2? Yes, itulah Vmax dia. And then we want to also identify what is the Km, Michaelis-Menten constant tu. Michaelis constant tu, we can find it where the line intercept the axis. Kat x-axis tu kan, nampak tak? So be aware that all this Km nilai dia negatif. Kan because dia dah ke kiri daripada 0 kan. It move to the left. So any line that falls after 0, before 0 ialah negatif. Let's say if that point, when you find out, ialah minus 4. So what is Km? Katakan dia minus 4. What would be the Km value? Tak ada negatif, betul? There will be no negative because it's already negative. It's already negative, so tak dia punya nilai dia tu. So what do we need to know Km? Contoh dia, what do we need to know Km? Km will tell us a lot of things. Is to show how well the enzyme and the substrate can bind. Macam tu. Macam mana dia, how well it can bind. So this is where we learn it in the inhibitor tu. Jenis inhibitor. It's quite straightforward lah yang ni for this one kan. This straightforward je pasal inhibitor tu. When you find that the graph that you want to plot, yang tadi tu, data tadi tu, you have to find what is the Vmax and you have to find what is the Km. Jadual you tadi, your table tu. Mana table dia tadi? Yang ni. Okay, let's say you do the same thing but you use different temperature, contoh. You use different temperature. Let's say this one is what, 35 degree? 35 degree ke? 35 degree kan. Okay, katakan you gonna have the same set of sample, but then you do it at let's say 40 degree Celsius. You buat kat 40 degree Celsius. You have one set is run under 35 degree, and then another set you do it under 40 degree. Maybe you have one more set, you do that under let's say 25 degree atau 20 degree Celsius. Lagi ada 3 jenis data yang berbeza kan. And then you can plot everything dalam satu keadaan, dalam satu graph. 3 line tu. Using the same thing, the same way that we discussed just now, but you can have like more lines compared to one line. Kalau you tengok dekat nota enzyme tu kan, you're gonna have like more lines. Ni tadi tu, double reciprocal tu. Yang this one can be example lah. Yang tu. Yang ni kan, you can have like more lines. Let's say now the black line is indicating no inhibitor kan, tak ada inhibitor. Tapi you can also like what I mentioned just now, I just change the temperature. System yang sama, I change the temperature, but I can also have the same set of research, the same set of what you're going to test, the same set of experiment, and then satu lagi ni you letak enzyme, lepas tu you letak inhibitor. Contoh, you letak satu inhibitor, maybe some chemicals, ataupun you nak letak maybe something that can compete with your amylase. Contoh lah, you letak satu bahan kimia lain, contoh So that is known as inhibitor. Once it happens, the way the enzyme react on that substrate will be different. Katakan yang pertama kotak yang sebelah kiri sekali itu, if you put in let's say a type of medicine lah dalam satu sistem tu, dia akan compete dengan the actual amylase. So if you plot the graph looks like that. The first one yang tak ada inhibitor, the same thing you repeat tu, you letak inhibitor, you do it the same thing that what you did for the first one tu kan, macam yang gambar rajah tadi yang dalam table tu. Bila you plot graph 1 over V dengan S tu, the 1 over S tu, dia akan plot macam tu. Dia nampak macam tu line dia. Jelas tak tu? In the first one. In the first box tu kan, on your left hand side tu. Bila anytime you see that kind of pattern of the lines, we know that ini ialah inhibitor tu ialah jenis competitive. Because they share the same velocity. Vmax tu kan, speed sama-sama, so they compete. They share the same velocity. So dia duduk macam tu lah. But let's say you run and you put in something else. Maybe you letak in some vitamin ke, you letak some mineral ke, something like that. And then it might shows contoh macam the middle one tu. If you see they have different Vmax, different Km. So meaning that is uncompetitive inhibitor. Uncompetitive inhibitor tu maksudnya dia tak compete dengan substrate. Dia tak compete dengan substrate. But what it does is actually change the whole enzyme tu kepada bentuk lain so that substrate cannot bind to the enzyme. Dia macam seolah-olah you sabotage lah. Sabotage active site of the enzyme. For yang competitive tu, you compete with the same substrate. The second one tu yang in the middle tu, dia tak compete for the substrate, dia tak kisah pun. But dia boleh bind to other part of the enzyme and make the enzyme substrate, make the enzyme active site tu tidak compatible for the substrate. So call like dia ubah bentuk enzyme, especially on the active site. So that is where we can identify from the graph. If the graph looks like in the middle tu, kita tahu bahawa that system contain a competitive inhibitor. Jenis-jenis ubat lah. Or medicine. I'm talking about medical lah, kalau medical kan. And then the final one on the far right hand side tu ialah they have different Vmax but they share the same Km. The affinity of enzyme and substrate, they share the same Km. So this one is different. Dia punya behavior dia different. That inhibitor dia competitive. Terbalik cakap ni. Terbalik saya cakap ni. Ya, mana dah? Non-competitive. Terbalik lah. Non-competitive. Dia go for allosteric non-competitive. Habis semua orang belajar yang tersilap pula saya cakap. Dia terbalik dengan uncompetitive. Yang uncompetitive ialah dia bind to the whole thing kan. Dia bind to the whole thing. Uncompetitive ialah the one that I mentioned tadi tu ialah competitive. Besarkan sikit line dia gambar rajah ni. Dah sini kecil pula tak nampak. Silap. Yang uncompetitive tu different Vmax, different Km. So yang ni ialah dia tak fight for that active site. What that type of inhibitor does, they can bind to the whole thing, to the whole enzyme substrate complex. The whole thing, so dia macam tak boleh bergerak langsung, tak boleh produce produk. Let's say kalau ada kerusi, kalau orang berebut nak duduk kat kerusi tu, itu kompetitif. Kalau orang tu ialah uncompetitive, dia biar je substrate tu bind pada enzim, dia biar je orang tu duduk atas kerusi. Lepas tu dia ikat orang tu, dahan kerusi tu. So orang tu tak boleh produce produk lah. Macam tu. Kalau misal kata yang non-competitive ni, they share the same Km. Tengok affinity, nampak tak tu? But then they have different Vmax. So ini punya cerita pula, dia tak compete for the same active site. Tapi apa dia buat, dia akan bind pada, the inhibitor akan bind pada allosteric site. So that it change the structure of the enzyme. Seolah-olah kalau yang di kerusi tu, dia tak berebut untuk duduk atas kerusi, dia patahkan kaki kerusi tu. So kalau macam tu lah, if you break that, saya betul tulis saya, kejap. Nak tukar phone, saya kena phone saya kat bawah tu kan. Okay, sambung. So meaning that if they don't bind the active tau, dia bind pada allosteric site. So once you bind pada the allosteric site tu, apa yang berlaku ialah they'll change the structure of the enzyme. So that is why we call it non-competitive. Faham tak? That's why we need to know Vmax and Km. So macam mana kita nak tahu Vmax and Km? Through what you showed just now tu lah, yang table tadi tu. Inilah kita perlu data-data ni. Contohlah when I did my research on ganja kan, so I extracted the active compound and see whether not dia boleh bind pada enzyme like this. Sebab ada yang cakap, kalau ambil ganja ni boleh kurus kan. So what I can measure whether not how does this active compound, what type of inhibitor of the active compound towards the enzyme of lipase ni. If I find the graph tadi, can you show me that graph? Yang tiga tu. Okay, normally it's gonna be that black line kan. But if put in that active compound in the system, and if that change uncompetitive ataupun non-competitive, dia berubah daripada asal. Betul tak? If I put in that FT compound in the system kan, and then I measure punya Vmax. Vmax dia tak sama macam yang normal. So that will indicate either one, sama ada dia uncompetitive or non-competitive lah, betul tak? Kalau misalnya kata saya letak dalam that system and then dia punya Vmax the same as yang normal punya, meaning that we know they share the same active site. So that will be competitive inhibitor. And okay, and then I can also measure the Km, the Michaelis constant. If it shares the same Michaelis constant as the normal one, different Vmax. So what is the type of that inhibitor? Non-competitive. Kalau misalnya kata dia tak share pun Vmax, dia tak share pun Km, different Vmax, so that inhibitor will be considered as uncompetitive. So that's the reason why we need to understand the kinetic of enzyme. Itulah cerita dia. So sekarang back to your data. If you look at your data tu dalam jadual tadi tu kan, there's a lot of things that we can ask you because the SF is higher than S naught. Shouldn't maybe you can ask around your other group whether you got the correct version. I'm not so sure why it does such way. Supposedly when you run your tag lighter in color in comparison to the initial concentration, meaning that you know that the concentration of the starch will be lower. Itulah cerita dia. So tak betul. So data is incorrect lah. Because you cannot, but sometimes in math you can use yang line kiri kanan tu kan. So whatever negative result you can go for, still you can consider that as positive kan. Tapi because you're talking about starch kan, you're talking about the thing, you cannot do that. Kita tak boleh nak make it positive walaupun nilai dia negatif. My suggestion is you can get the data from your other friends. You can still have this data published in your work, in your report, but know that something is not right, right? So you just mention lah, sepatutnya benda ni tak berlaku. The thing is that when you do things that's not as what you expected it to be, you can just give reason and justification to show that you know what's supposed to be found and you know what's supposed to be calculated. Tak ada masalah. So maybe you can get other friends punya data and then you can learn how to plot from their data. Apa, belajar. Ya. Live work tu. So for your standard, okay ke? Bagus lah. You punya standard. Okay. But it would be good if you don't make it reciprocate at y and x-axis. Otherwise, your equation will be y equal to mx plus c. There's a c to it. Because you're going to start off with 0, 0. Yeah? Macam mana? Okay, line kita, when we do a curve or line, your equation will be y equal to mx plus c. Plus c means the line is reciprocate, is intercepting paksi y. Kalau ada plus c tu. So get it to be 0 c to 0 sebab kita kena start with 0, 0 because our concentration is 0 And then remember that you zero the concentration. You letak zero starch, zero absorbance kan. Like the one that you plotted warna hijau tadi tu. Yang tu dah okay line dia tu. You just get the line dia apa je. Equation dia apa. Because you have that C. 0.33 tu kan. So that 0.33 tu lah dia intercept Y, paksi Y. You, yang hijau tu okay. Yang hijau punya line tu. Yang merah tu because dia nampak dia cross dua. Intercept X and Y pula tu. You cannot do that. You cannot use that equation. Katakan you punya paksi tu ialah 0. What is the one that intercepted it? 0.03 kan? Kalau you dapat 0.2, so what is your concentration? Tu 0.3 betul kat C tu. Tengok balik graf tadi. Okay, yang line merah tu, yang intercept tu ialah 0.3 betul tak? Itu 0.3. Tapi katakan you dapat data 0.2, so what is your data? Dia akan jadi negatif. Betul tak? If you plot 0.2, dia akan, if you want to intercept the line, dia akan jadi negatif. Negatif 0 point something, which is incorrect. So 0 is 0. It should be 0. Sebab you punya C tu banyak, 0.3. If you get like 0.003, itu acceptable. Dia nearly 0. Because you punya 0.3 kan. 0.3 is huge, besar. Kalau you dapat 0.003, tu near to 0. Kita bolehlah just abaikan C tu. Tak boleh ubah. You tengok line hijau tu, you ambil trend line. You can get that data, you can paste it dalam Excel, and then you get that trend line berapa yang tak ada zero. Kalau you dapat zero yang rendah, 0.003, 0.00 tu, you just biar je equation tu. Ah, yeah, yeah, correct. Okay, habis.
Doktor, kalau saya plot guna Excel boleh ke?
Boleh. Guna je apa-apa pun. Guna kertas graf pun boleh.
Okay, baik.
Patutlah you pun pening kan. Tak apa, it's a learning process. Sometimes when you learn, not necessarily you're going to get all answers. You're going to get failures, you're going to get mistakes. Biasalah. Belajar. Kalau you dah perfect semua, kita tak payah belajar dah.
Doktor, so saya punya data ni.
Tapi you can still use the data, you can still publish it. Tak payah ubah data. Data yang whatever you have, that is what you have. That is what you get. Just publish it in your reporting pun sama je. But you define balik, you just do some justification. Why do you think that data is totally wrong? Boleh macam tu.
Doktor, kiranya kalau plot graf kita orang pun salah pun biar
Kejap.
saya sekali ni sebenarnya, sorry lupa nak cakap.
Siapa tu?
Luffy.
Kau tiba-tiba kan nama Nur Filzah ni yang keluar kan?
Bukan. Kami tengah buat ni, lab report ni lah.
Ha.
Kita orang guna Excel, and
Okay.
then kita orang ada problem dekat delta S lah sebab
Dapat negatif.
SF kita orang tu tak tahulah macam mana dia dapat negatif. So bila kita orang plot graph dekat Excel and kita orang buat line graph apa semua, dia akan start daripada bawah. So kita orang still stick with the data ke macam mana?
You can still stick with the data, no problem. But you
Then we
now that you
justify
understand the
what's
whole story, yes.
So kita orang justify lah apa yang kita orang salah and explain balik lah kan apa yang betul.
Yeah, exactly. You tak payah pening-pening. Walaupun data tak betul, you just tunjuk apa data kita dapat kan, and then you mention kat situ supposedly you cannot get any types of a good Vmax or KM because of the data. The data itself is inaccurate. The data tu pun salah. And then you can try to reflect back. What did you did? What wrong? Kat mana yang kesilapan yang tak dapat data? You punya tu ke, you punya solution pekat ke, you punya apa ke, you just track back and recall balik which part that makes the data is inaccurate. Tak payah tukar-tukar data, tak payah. Whatever you have. But if you maybe you jumpa observe your friends punya data dia macam data dia okay, data dia betul. So maybe you can pinjam the data and on to your report. Tak payah tukar data. Whatever data you got, that is your data.
Okay.
nanti
That's only the
kita-
problem in our that report. The report ni, so kita orang start kat discussion je sebab graph ni yang salah. So kita orang punya data lah yang salah sebenarnya. Alright doktor. Alright, thank you doktor.
Yeah, no problem. You all buat satu sekali ni ramai-ramai ke?
Macam mana doktor? Saya
Tak.
group lain, Filzah group
Ah,
lain,
iya.
Rashmi group lain. Kita orang
apa.
nak confirmkan kita orang punya graph plotted tu sama ataupun tak sebab kita orang start dekat table SF dengan delta S tu je sebenarnya. Yang lain so far okay.
Sekarang dah faham.
Saya dah tengok video dekat YouTube. Data dia orang semua positif, so kita orang macam agak confused lah sebab kita orang punya data dapat negatif. Itu je.
Yang kita nak negatif COVID je.
Apa dia doktor?
Negatif COVID.
Okay, faham. Okay, saya slow. Alright doktor, nanti kita orang try compare dengan group lain punya data lah.
But stay, let your data stays in your report.
Alright.
Just mention kat mana what went wrong je.
Alright, thank you.
Okay. Ada lagi? Yeah, you're welcome. Ada lagi? Dah habis.
Ada lagi.
Okay. Tak apa. Kalau ada soalan nanti tanya je. Alright.
Terima kasih doktor.
Okay. Sama. Bye. Assalamualaikum everyone.